Hello, welcome to this, the May edition of EdinburghJS. My name is James. I'm the enthusiastic junior engineer who got roped into filling in for Jamie tonight. We have two fascinating talks lined up for you. What we do not have lined up is a fire drill. So if the fire alarm goes off, please exit the building using the door that you came in by and follow the instructions from the Code Clan staff. If you would like to go to the bathroom, it is behind you and on the right. This event is being live streamed, so if you do not want to appear on camera, please do not come onto the stage. Our first talk, where are you, Rory? Are you ready? Yeah. Come on down.
Hello everyone, it's great to see some people that I've known before come to this meetup, people that I've spoken before. I'll try to match their interesting talks. So today I'm going to be talking about full stack type safety, what it is, why you should maybe care about it, why you'd find it interesting. So first things first is, I'm Rory Malcolm. Normally people can't really work out that my website URL is a bit of a play on my last name, but when they're written next to each other, you can see that that's where it is. So I'm reachable at rorymal.com, and I'm also reachable at github.com/rorymalcolm. I work at a startup that builds dark kitchens, which are warehouses on the edge of cities that sell delivery-only food. But this talk's only about 15 minutes, so I can't really go into much about what that's about. And then before that, I worked at the Government Digital Service on gov.uk, particularly at gov.uk, a service called gov.uk Pay, which you might have used to pay for your driver's license, or if you wanted to drop the curb outside your house or something like that. It's used for a whole variety of things. And I'm largely a back-end engineer. I'm a back-end infra data engineer, whatever you want to call it. This just basically means I don't know CSS. But I have worked in the Node ecosystem for most of my career, and I've got a secret. And that secret is that I've never been a proper JavaScript engineer. So I'm a bit newer to JavaScript than a lot of people here. I started working professionally with it in about 2018. By this I mean I don't know what jQuery is. Most of the code bases I've worked with were written in TypeScript. Before that, I worked on university in JavaScript, but limited experience. And I'm very much of the post-TypeScript, Flow, Elm, PureScript. Are there more? There are. I can remember them. But have worked within type checkers where you have some harness that sits on top of your JavaScript, and I'm sort of been informed of using that experience, and I'm biased towards liking these tools as opposed to not liking them. So enter David Heinemar Hansen. So he's a software engineer and racing driver from Denmark. He's quite opinionated, has published a lot of blogs over the years alongside his business work. And I'd say that so for example, he biases towards having on-premises stuff as opposed to running things in the cloud. He would say love the monolith until the monolith doesn't love you back. He wants to keep things as simple as possible. You should have simple architectures that allow you to move fast, and you should bias towards keeping things in that mode of operation as long as you can. And basically the costs of making things too complicated to begin with are not worth the sort of eventual skill benefits you might get or whatever. So sort of say keep it simple for as long as possible is his sort of mantra. And first, I think just take a detour off Rails. The thing that David's probably most well known for is he wrote a framework called Ruby on Rails, and for a long time, this was the lingua franca of a certain type of web-focused company. GitHub and Stripe were all originally written in Ruby on Rails, and still to this day maintain massive Rails code bases. Stripe even maintains a thing called sorbet, which is kind of TypeScript for Ruby. So within Rails, etc., the fingerprints of this sort of simplicity for as long as possible attitude all the way across Rails. And I think that a lot of the reason that Rails was so successful was because of this. And if you've never seen it or you haven't seen it in a while, there's like an initial demo where David introduces Ruby on Rails to like the wider community and goes through like setting up a little simple app and stuff like that. And I basically think it's the best tech demo of all time. And I think that like you can just so clearly see what he is like wanting to achieve with it, and he's like really good at explaining it. And everything that came afterwards, like Laravel, like even Express, like a lot of these battery included frameworks are sort of in the shadow of this like particular talk. And although the stuff today I use today isn't nearly as good, and basically if you go away and you're amazed by this, just don't remember the rest of my talk and just pretend that that was I introduced you and link them in your head. But yeah, like really worth your time. So yeah, like arriving at the station. So like recently, TypeScript has been like a bit of a target of his ire. Like he has sort of said he was very much like someone that likes the old JavaScript way, and he thinks that TypeScript is like an unnecessary complication. He doesn't see like he just describes it as type hints in this tweet, and I think this is like a sort of view that used to be quite common. Like TypeScript's just getting in my way. I just want to write JavaScript. I loved writing JavaScript. And it's also quite like a Rubyist view. So like comes from the Ruby programming language, and if you've ever seen anyone that's really good at Ruby use it before, like they often do everything in one line, and it's like they don't want the type checkers getting in their way. They know what they want to write, and like I don't think he's wrong for his sort of like use of TypeScript. But yeah, like what is like TypeScript? Is it like an entirely different programming language to JavaScript? Is it just a different flavor of JavaScript? Or is it just type hints as David describes it? And I basically think it's the best when it's just type hints. Like the thing that I first loved about TypeScript as a comparison to JavaScript is that the autocomplete was better and it understood my program a bit better. And I think that this is the reason why it's like won against its competitors in industry, etc. And I get why David doesn't like this, but I really, really like my better autocomplete, and I will fight as hard to get better autocomplete if I can. So yeah, like there's also, as well as that sort of critique of like TypeScript gets in the way and there's a lot of stuff that's appealing to the compiler, there's also what I describe as my like sort of here be dragons view of the TypeScript documentation, where like the top of the TypeScript documentation is sort of like here's what type is and stuff like that, and then the bottom half is just all scary things with the word types at the end. And like I think that like there's like a sort of critique of the TypeScript ecosystem that like they basically completed it in about like 2016, and just the rest of it has just been like this academic exercise of adding more and more complexity on top of that. And I've sort of like crudely cherry-picked people that had this opinion on the Orange website. And like, so like people are saying like it has the most complicated TypeScript type system ever. I don't know why they needed to go that far. And like, I love the types, but it's becoming so complicated that it's not what it once was, right? And so as well as this critique of like not liking TypeScript to begin with, there's this also critique that like TypeScript was good, but it's got like way too complicated, and I don't see any benefit from that, right? Like these are the two things that I think are like relatively common opinions. But I actually think there's a reason for this, and the reason is that like JavaScript itself, which TypeScript is trying to like capture at the type level, is just like really complicated, and it's complicated for a reason, right? Like over time we have like added more features to it, etc. So like if you're trying to represent the sort of entire scope of JavaScript at the type level, like your type system is just going to really need to be really complicated, and like maybe you don't have to touch this stuff all that often, but if you're like a library engineer, like we'll get on talking about, like you might need some of this complexity in order to be able to deliver the right abstraction on the complexity later down the line. So yeah, so what is like full stack type safety? And I basically think it's a marketing term, if I'm honest, but it's a marketing term that's useful, and it groups a load of libraries which have sort of recently popped up in the TypeScript scene, and I think that they all have like a similar like view of what TypeScript libraries should look like, and I think it's useful to group it under this umbrella, but I actually don't like the term that much. But yeah, like basically what it is when sometimes you're dealing with like an external component, and this can be like a network call to some API, it could be a database, it could be like the file system or whatever, and because this ambiguity exists, when you bring something in from a database or whatever, it's often like typed as NA, and you just have like, you have to sort of appeal to the compiler. You have to say, no, this is actually a string or whatever. And you spend a lot of time doing defensive programming up front in order to be able to actually reason about this thing that you fetched from the database down the line. And what these libraries are, is they basically have that defensive mechanism built in so that you can, when you talk to the database, there's a lot of complexity that abstracts that database call to you, but what you get out is really simple to deal with. And I have examples of these libraries and what they do and what the end result looks like later down the line. So yeah, basically what I'd say full stack type safety is like it hides a lot of this telling the compiler what it is and making sure that this input that you've received from some other source, it matches this type specification that you've given it, and you don't have to check that yourself. So yeah, enter general Zod. So Zod is like a library that is the basis for quite a lot of this. What happens in Zod is you build a schema, and then when you receive some input, so when you receive some like user input or some form input, you use Zod to validate that that input matches the specification that you've given it, and you have type safety afterwards, right? So like after you've dealt with that, the boundary of whenever you see this user input, every interaction you have down the line and downstream in your code is then like type safe and validated. And I have like, I sort of explained it earlier, but there was going to be some live coding in this, but I'm kind of glad that I stabbed my finger when I was cutting basil last night, and it's really sore, so I'm not going to type it, I just have screenshots instead. But this kind of illustrates what I'm on about, right? So we have this horrid API call here. Say it's something that's unreliable, maybe you get like something in different formats all the time or whatever. So, but we know that this horrible API should give us a name and a mood. So the mood is either nervous or confident. And then we should also receive a talking for, which is a number which is positive and is greater than or equal to 5, right? So like we couldn't express that sort of stuff in the TypeScript type system because it's not like dependently typed. We can just say something's a number or it's a string. We can't reason about the actual values. But because Zod runs at runtime, it can like check this sort of stuff. Like it can make sure that the number is bigger than 5. So when we do the horrid API call here, and we get the result of it, we then like parse it against this schema. And if this is wrong, it'll throw an exception, and we can handle that and say like this is not actually what we expect. But every interaction on from it is completely type checked, and we know that it has a name, and we know that it has a mood, and we know that it has a talking for that exactly match the specification we've given it. And like as soon as you've done this parse statement, any interaction from that onwards is like guaranteed by the compiler to be correct, as opposed to sort of where you have to chain things in a load of like, oh, it might have a name, and like you have to defensively check for undefined onwards. What Zod is like really good for, and like why I love it, is that the compiler, after you've done this parse, Zod returns like a type that is just name string, mood is a string literal of nervous and confident, and talking for is a number, right? And like the compiler provides these guarantees, and you're just dealing it with it like you declared a constant further up the line. But like and I've sort of written like, why do we need more complex types for Zod? Zod's internal code base is like about the most complicated TypeScript program I think I've ever seen. Like it's so incredible what he does, and I don't understand basically any of it. But he has like Zod strings instead of strings, and he reasons about this Zod string, and it's an abstraction over the TypeScript string type. And they basically take the entire TypeScript system and sort of re-implement it inside the Zod library. And like sometimes when you deal with some library in TypeScript, you get some absolute alphabet soup of a type signature. But the beauty of Zod is that they've done loads and loads and loads of work, so that even though they deal with all these things on the internal, like the Zod string, etc., the type that you get out looks like a normal TypeScript type that you'd written, and like it is just. I have like all the demos and screenshots or whatever that are available on GitHub, and if you're at all interested, I'd implore you to download it yourself, and you just see that the signatures you get back are normal, and it's not some like horrendous alphabet soup. But there's like a problem with Zod, right, which is that you have to like write all these schemas out, and this can be quite tedious. So maybe if we already know the schema, like if we're using a database, we might have a copy of this database schema that exists already, and maybe we can like generate something based on that schema. So Prisma is like an ORM for interacting with a database that generates like a TypeScript client for you that's like fully typed, and it's aware of like what's in your database, and it basically, I mean, I can show you here. So if we like seed the database here, and then we just like find the first talk, And then if there's not a talk found, we throw an error. But like it knows exactly, and like the things you deal on with it, there's no like error under that. We just get like a normal TypeScript string out of it, and like it hides all of the database connection from you and just returns something that looks like a normal TypeScript type. So I have like a SpongeBobify function here, which like capitalizes every second letter, and like the compiler knows as soon as we've like done this, Prisma hides all that interaction with the database from you and just returns like a really nice TypeScript type up the stream. And so yeah, this like is the result of the output of that. Yeah, and so like why do we need more complicated types for this? And it's just because you have like a schema, which is like a list of all your database tables and the types and the indexes on them or whatever. And like some functions only need some of components of these schemas. Like if something was a primary key, you maybe don't need to create that. So like we need a more complicated type system in TypeScript just to be able to model the relationship that database tables have between each other. But if a library developer can do this stuff, they can then hide it from you, and the actual end interface that you get is like really nice. And then finally, the last one we're going to talk to you about tonight is called TRPC, which basically just does the same thing, but for talking to like a backend API that you might have. So TRPC uses Zod under the hood, and it interacts with all the major like backend frameworks that you see across the Node ecosystem. So that's like Express, Fastify, Next.js, API routes, and stuff like that. So it allows, it's basically TRPC you can include on top of your current stack, and it gives you this sort of type safety. Yeah. So TRPC, like this is an example on the server. This is using TRPC's backend framework. So like this is actually like quite a contrived example that's like maybe not that pretty. And like normally it would be like within whatever backend API you're using. But like you can see here that I've defined that like user by ID is like a root. And it takes in like a string as an input, and then it returns, it would normally interact with the database here, but it just returns the ID and my name. And then we also have like user create here, which takes in a name of a string. So like this is, yeah, it knows what you take in and what you output. And TRPC sort of goes along, and you put your stuff within this harness, and then the result that you get of this is like a really, really nice typed library that totally understands. So this is all type checked. It knows that if I'm doing a user creation operation, that we take in a name and a string. And the user, if we're fetching a user, it knows that we take in an ID, right? And we get a really nice TypeScript native response here that we can just easily ship into our code, and we don't have to do any defensive programming to ensure that what we've retrieved like is nice or whatever. It just works, and like it's a lot nicer to work with than generating a client library or whatever yourself. And the other thing that's kind of great about it is because the front end and the back end are sort of implicitly linked here. Like say if you change, like you have some API endpoint that wants to take in a new parameter, then the client library here, if you don't update the client library as well, it'll refuse to compile because there's a type signature that's shared between your front end and your back end, and it is aware of like all the instances at which this API is being called. Cool. So yeah, I mean, it's basically the same for Prisma. Like it needs to have some understanding of the difference in the client and the server and the type operations that are like done across them. It needs to know where it expects some parameters and where it expects others. So like the complexity in the TypeScript like ecosystem allows the engineers that build TRPC to model that accurately. And it means that the consumers, like all of it is just hidden from me because they've done the hard work for me. Yeah, so like what is this mean for David and the others? So like some people will never stomach the boilerplate, and that's like totally okay. But you do just get like, if what you care about in TypeScript is better autocomplete, which is what I care about, and a nicer developer experience, this stuff will give you like the autocomplete that you first got, but like on steroids, and you no longer like you can call a spade. You no longer have to say const x as spade, right? Like you know that you're dealing with a spade, and you don't have to tell the compiler over and over again with what you're dealing with. And it removes like a load of defensive programming that you quite regularly have to do in TypeScript if you're dealing with downstream dependencies like that. It lets you get on with writing the business logic you want to write. And that's because like the TypeScript team have been picky about what they implement, and all the advanced stuff that they add is not really for like developers day to day like me. It's more for library engineers that want to take the weight off my shoulders. So yeah, like the conclusion is just the TypeScript team are really good at the jobs. They picked good choices, erring on the side of like just enough complexity to be able to deliver like really good developer experiences like this. I'm basically rephrasing what so what I would say though is all of these libraries are like relatively new, like within the past like 3 years or whatever. So like when everyone was complaining, and maybe rightly so, that TypeScript was getting really, really complicated, the library developers are like finally being able to leverage the complexity that was added in the type system, and the developer experience we're getting because of that downstream is like really, really good. And like there's a load of exciting stuff that's happening in this space, like using Zod, etc., to power these sort of libraries for basically any time that you deal with some downstream thing like this. And yeah, so thanks. The code base for all this is available there on GitHub. And if anyone has any questions or comments, I'm happy to take them. Sure.
Team test represents. What do unit tests look like using Zod?
What do unit tests look like? So it's kind of the same as it would be otherwise, right? Because like, although Zod gives you an extra guarantee that while you're running your program that the execution is going okay, like you still want to test the inputs and outputs, right? You want to be able to you want to be sure that when you put in some junk code, the way that you're using Zod is actually validating that up front, right? So although Zod might give you some extra sort of like guarantees when you're writing your code that the types are correct, I still think you want to have unit tests that do try and like ram that square peg down that triangle hole just to make sure that you are capturing this straight away. What I would say is if you are a cowboy like myself and you maybe don't write as many unit tests as you otherwise could, sometimes this gives you the confidence to do that, is what I would say. Yeah.
Thanks, Rory. Really, really interesting. I got a question about Prisma. So you can basically point it at any database, SQL Server, Postgres, whatever you want. So it must derive somehow then from the database, as you said, the schema for each table that you access.
I've hidden some complexity.
There's some magic there somewhere, which I'm not getting.
I've hidden some complexity from everyone here. So in Prisma you write like a schema.prisma file, and Prisma has its domain-specific language for like writing database formats, and then it generates the migrations for you, okay? And then you build a client library, which is based on that. So Prisma chooses to have an external client library, so like it has a Prisma file that you then generate your database schema from. But there are newer attempts at doing this. So there's a new database ORM called Drizzle ORM, which attempts to do this like similarly to how you define schemas in Zod in TypeScript itself. So Drizzle does that. It's like a similar approach, right? Where you create the tables in your TypeScript files, and it has like it gains its knowledge of the database schema from that, as opposed. And because it does that, you don't have to generate it. So Prisma, there's an extra build step as well. So because it has to take that schema.prisma file and generate the client, but because with Drizzle, you do it all in your code. The client is sort of generated within your code, and you don't have to run this extra build step. The reason I was gonna display Drizzle instead of Prisma, but Drizzle's really, really new, and I was like last night at like 11 o'clock was trying to build my example, and I couldn't get it to work in the time frame, so I was like delete, and I've used Prisma instead. So that's like an example of like something that's exciting down the line, and I think they'll get there. It's not impossible, but like there's a reason that I use Prisma instead of Drizzle tonight. Yeah.
Yeah, thanks. Really interesting. You could derive it from the database directly.
Yeah.
And if it was doing that, that would have been quite interesting to see how it does that. But yeah.
So Prisma has like, there is like a dump utility, right? So if you're doing migration from like Sequelize, which is the other popular like node, you can like dump your database to a Prisma file and it will generate it for you. Yeah. No.
I have actually 2 questions. One of them, why not GraphQL, which is quite similar and which was initially in Prisma. I don't know what about now, but initially it was on GraphQL.
Yeah, so the reason, basically the reason is I've never worked somewhere that used GraphQL, and what I quite like about this is although that I have to do some ceremony, I don't have to like spin up like a GraphQL server, and I basically think this gives me like a GraphQL style developer experience, which is great, without having to do the stuff that GraphQL required. And like maybe it's just my naivety and I missed the GraphQL boat, but like I think that this is kind of GraphQL-like, and like I've seen people have to run stuff like Hasura or whatever in front of their databases, and it just always seemed complicated to me, whereas this maybe doesn't.
You can use in any framework the GraphQL server the same way as with TRPC.
Yeah.
I mean, and also a lot of very similar things, but I think it's maybe more about to moving away from the GraphQL specific language, I would say, to the more like a JS kind of.
But what is probably good about GraphQL and what's maybe bad about these tools is if you're using these tools, like your front end and your back end all have to be in Node, right? Like they all have to be written in TypeScript, whereas GraphQL maybe gives you that sort of like independence in like language choice, right? So you can swap the servers like runtime or language or framework or whatever out under the hood. Yeah.
Even the language, like Prisma's language is the GraphQL.
Okay. Yeah.
That's and second question, is this running are you running this on on all environments, on dev, prod, or and if you're running, why you're running, let's say, on prod?
Yeah. So I mean, we deploy our same code base everywhere, right? So like if we're interfacing with our dev DBs, we do it through the same ORM that we do in prod, right? And we like our code base uses these tools. We don't use TRPC, but we do use Prisma and Zod, and like we run them everywhere. We deploy the same code everywhere, and I mean it's does that answer your question?
I mean because let's say about the TypeScript, if let's say by using TypeScript, you're not bringing it into the prod. Like you have TypeScript only in your dev environment.
I get what you mean. No, so yeah, we're not using like one of these we're not using like Deno or whatever that runs TypeScript by default, right? Like although these abstractions and good guarantees exist when we're writing our code, but obviously we transpile that to JavaScript and all the parts.
So they're getting disappeared.
It's a compiler guarantee layer, but then obviously it reduces the amount that you see like stupid bugs in runtime because you do this. But unlike Elm, which we'll be talking about later tonight, you don't have the same sort of guarantees of like no runtime bugs, right? Like you're still dealing with like some leaky abstractions that could exist. Yeah.
Yeah. Great. Cool. Thank you.
It feels, I mean, I'm someone who's coded in JavaScript for a long time, and I've only just started moving over to TypeScript after multiple times of putting it off. That I'm endlessly dealing with schemas now. I'm dealing with schemas that relate dynamically to pulling stuff out of databases. When I want to create REST APIs, I need to do JSON schema to do the documentation so I can kick up Swagger or an equivalent. And actually, although the TypeScript seems really well contained within itself and works quite well within the library or whatever code I'm doing, as soon as I go out or in, I'm in a mire that's created by these crossovers of schemas. Is this really going to help fix that problem?
What I would say is like the beauty of Zod and the fact that a lot of these tools are using Zod like under the hood is that Zod is like the glue. So like maybe in the future you can have like TypeScript types and then you have your Zod schema, and like the Zod schema can be kind of portable across these tools, right? Because they're all using Zod under the hood. But like I totally agree with you, is like this is a big problem. But one thing that Zod has that's really cool is that it has like a type level function called Zod.infer. So you say if you have like a type, right? So say you have some user form, okay? You can say like type user form input equals Zod.infer, and then you pass the Zod schema into, so you don't actually have to write a TypeScript type, right? You write the Zod schema and that gives you the TypeScript type for free. And like I've seen people use that to have to reduce the writing a TypeScript type and then writing the Zod schema and like making sure they interact together. So like maybe something like that's the future. But like I mean I basically agree with you, like the schema stuff's like really complicated, and like all of these tools that are meant to convert things together are just like a bit leaky, and like it does feel that you're a bit mired in all this. So like I don't know what I would say. I just I basically agree. Yeah, and I'm not sure that this has been totally solved yet, and I'm not sure if it's 100% solvable, but I've basically found the pay down that we have to do to use Zod a lot to be worth it. But anything beyond that, like I'm pretty, not skeptical of the word, but like it would need, if I was writing another spec for the same chunk of data, I'd want to be sure that was like worth it. Yeah, yeah.
Have you looked at any alternatives like gRPC?
Well, so yeah, like gRPC is obviously great when you've got like a polyglot like language. Like, so if you have some like big, if you're generating using a thrift file to generate client libraries for everything, right? Like that's really great. But I think like the beauty of TRPC is it's like TypeScript native, and like they've really focused on getting like a really good TypeScript experience, because like I think in a lot of even the really big client libraries that are used, they're automatically generated. Like AWS is, like the entire AWS node library is like generated from their thrift files. And like until December, S3 get object, like probably the most common like runtime operation that is used in the entire like ecosystem, didn't have an ability to like give you a string automatically. Like you had to read it to a bucket. And like because TRPC is like actually in your code base and like you're writing the like type signatures yourself or whatever, there's like a level of TypeScript nativeness that just makes sense that I don't think you get in the same way with generated client libraries for every language. Yeah, but like I mean, I love gRPC and I've used it a lot and I think it's great. But I think if you're talking from like a TypeScript front end, TypeScript back end, I think TRPC, it's not exactly the same paradigm either, but like I think it feels better. Is this what I'm trying to say? Yeah. If you can afford to cheat, do it. Basically, is like what? Yeah.
Any more questions? In that case, please join me in thank you, Rory, for this amazing talk.
Cheers.
We'll have a 5-minute break for whatever you need to break for, and I'll see you here in 5 minutes. Welcome everyone to part 2. We have another fascinating talk up for you. This is Ross.
Hi there, I'm Ross McKelvey. I'm going to be giving you an introduction to the Elm programming language today, which Rory mentioned a bit earlier. So I have been working with Elm for about 3.5 years now. My biggest Elm app has about 13,000 lines of code. We've got a few smaller ones as well. So I'm a freelance security consultant and full stack developer. So you can hire me. You can find out more about me on my company website and also on my LinkedIn profile. So what do I expect you to get from today? So first of all, I don't expect you to be fluent in writing Elm apps when you walk away from here today. But the Elm website does have a really, really excellent tutorial that if you're at all interested, I recommend that you work through. It's got a really nice gentle learning curve. So the other thing is this presentation is in fact an Elm app. So I've not quite been organized enough to put it up on GitHub yet, but I will do so, and I will send a link out to that in the Discord channel. So I'm going to talk a little bit about what Elm is, where it came from. I'm going to talk about what it can do, and most importantly, I am going to talk about why you might want to use it. So I am aware that often EdinburghJS meetings, there's quite a mixed audience in terms of experience and abilities. I'll ask for a show of hands at a few places. I'm going to try really, really hard not to use jargon. If I do start using jargon, if I say something you don't understand, you will not be the only one in the room. Please stop me and shout, and I will go back and explain what on earth it was I was talking about. There is time at the end for questions, so if you've got a kind of more meaty question, if you can save that one for the end, that'd be great. So what is Elm? So Elm is a programming language specifically designed for building, specifically designed for building front-end web apps. So you can use it for full single-page applications. You can also sneak it in just to control a single element on a static page, or indeed have it running alongside another framework. So you write in Elm. It compiles down to JavaScript, which is principally ES5, and it was written by this guy who, when I was watching some YouTube videos, I've heard him pronounce his surname differently on different occasions, so I'm going to go with Evan Splitsky. So this guy, he was doing his computer science undergraduate at Harvard back in 2012, and he wrote a thesis, and Elm came out of that. So if those of you who have as little hair as me can cast your mind back to that time, there was a lot of activity in the JavaScript world around that time. So you've got so AngularJS, the first one was launched in, I'll have to remind myself, 2010. You had Ember in 2011. You've then got Elm in 2012, React 2013, and Vue in 2014. Now, I've used Ember and I've used Vue to build front-end web apps. Elm just is by far and away my choice of tool to be building web apps. So Elm itself had a lot of breaking changes right up until about 2014. After that, Evan, who's still maintaining it, he really focused on optimizing it and simplifying it as a tool. So the latest release was actually in October 2019, and that's 0.19.1, which he described as intending to be stable for some time. And indeed, since I've been using it, that's the version that's been out there. So it is used commercially, but it'd be fair to say not as widely as something like React. Why? I don't know. I think it's amazing. It doesn't have the same corporate backing, perhaps. Who knows? But it does, as well as being the language, it also has its own repository of packages, and it's got its own tooling as well. So I'd really, if I were replacing it, I'd sit it very much alongside frameworks like React and Angular. Now, as you can probably tell, I think Elm is awesome. And why do I think that? Because you're probably thinking, you know, I've learned about 4 or 5 JavaScript frameworks. Certainly, if you were fiddling around with JavaScript back 10 years ago, you know, they came and went. There was kind of no point learning stuff because it was changing so fast. So let me tell you why I love Elm. So I really find it a pleasure to code in. I code in a number of languages. Elm is just nice. It feels good. You feel productive. Some languages I feel like I'm fighting, and I feel like Elm is totally the opposite to that. It really kind of points me in the direction of where I want to go. Indeed, as Evan Splitsky actually recommends in his guidance, that you don't design your applications from the off. You kind of just let them come, and they do. And it's strange in comparison with some languages where if you don't design it right from the start, you've just got a nightmare ahead of you. With Elm, refactoring is just so easy and so safe, and that's partly because of the type safety. Because it's compiled, you discover your bugs much earlier in the development cycle. I am definitely a developer who likes discovering bugs at compile time and very much not at runtime. And in fact, Elm makes some quite bold promises about having no runtime errors in practice. The documentation is great. There's documentation on all the official packages as well. And I find that if it compiles, it runs. So I spend a lot more time in Elm writing code than I do writing unit tests, which is not to say that unit tests aren't important, but I feel much more confident about my Elm code than I would, for example, about equivalent JavaScript code. Now, I was talking quite enthusiastically to a guy a few weeks ago who used to develop in Elm and now left that company and now codes in React. And he told me that he cries a little bit every day, which I thought was very sad. He misses Elm that much, and he was that excited talking to me about it. So hopefully you will find that too when you come to it. Now, how does Elm achieve this level of awesomeness? So I'm going to ask you to activate your jargon klaxons because it is a purely functional, statically typed language with immutable values. Dun, dun, dun. So what do these things mean? So let's break this down. Right, first of all, if I ask about statically typing, who has used a statically typed language? Could you please raise your hands? Okay, who would know what statically typed means? Not even the people who use statically typed languages, which is a little bit of a surprise. So JavaScript, as you may well be aware, is a dynamically typed language. So you can do all sorts of fun things which you may or may not intend. So don't get me wrong, dynamically typed languages have their place, very quick to code in. If I wanted to shove something together really fast, Python, quick and dirty, perfect. But you can do some great things like this. So in JavaScript, if you add foo and 3, it will helpfully give you foo3. And if you try to take a number away from a string, it will give you not a number at runtime, and that's a valid result. So that's what you get with dynamic typing. Elm, however, does not do dynamic typing, it does static typing. So that means that everything has a type, and it has a type that does not change. So that means that if you try to add a string to a number, it will say no. And in fact, Elm actually has excellent error messages. I just didn't have the space on the slide. It will tell you exactly what you've done wrong, and you can go and fix it. So static typing means that there's a whole host of problems that you just don't need to encounter. So, for example, in Elm, there is no null. There is no undefined. And therefore, nothing can ever have those values. Okay, purity. Who would be confident they would know what a pure function is? Okay, some confidence. Who has ever used a language that only accepts pure functions? One. Okay, so purity. So purity is where a pure function is where the output of the function depends only on the things that you give it, only on the arguments, and on nothing else. And moreover, it does not do anything else whilst it's running. So it doesn't have what's called a side effect. So if you can, I don't know if the text is big enough on the screen to see. Okay, so top function. So it takes two arguments. It uses those arguments. It doesn't use anything else. It doesn't do anything else. That is a pure function. If you feed that a set of values today, it will give you a result. If you feed them the same set of values next week, it will give you exactly the same result. That's what a pure function is. Now, there are some impure functions. So, and from a JavaScript perspective, there are some things that you might not think of as impure that most definitely are from an Elm perspective. So, getting the date. So that's not pure. And the reason it's impure is because if I ask it today, I'll get one answer. If I ask it next week, I'll get a different answer. So that's not a pure function. Similar with generating random numbers. I'm not going to get the same result back each time. There are some other examples as well. If you log to the console, boom, that is an impure function. So if you have a function that does stuff, maybe it returns a value, it logs to the console in the meantime, that is not a pure function. Why is that important from an Elm perspective? It's important because Elm only has pure functions. There are no impure functions in Elm. It is not possible to write an impure function in Elm. Now, what that means is that some things are a little bit more tricky, like if you want a random number, or indeed just getting the current time. But in exchange for that little bit of trickiness, you get code that is just so much easier to reason about, much easier to read, and crucially, much easier for the compiler to optimize. So particularly if you're working on an application where you're concerned about asset size, with pure functions, you can ensure that you can eliminate the functions that aren't used, the dead code. It just goes away. So in Elm, if you want to bring a big library in to use, and you only want to use one little bit of it, that's fine, because from your production code, only the bits you use are going to be included, and that's quite easy for the compiler to do, in contrast with the kind of equivalent options in JavaScript. So immutability. Who has used an immutability library in JavaScript? So Immer or EdinburghJS? Yeah. So we've got a few. Okay. So immutable value. So if things in JavaScript are mutable, so I can define a variable. I can have my x. I can say it's equal to 1. I can then add 10 to it and set it back to itself, and that's absolutely valid. In Elm, that is not valid. You define a value once, and that's it. There is no opportunity to change it. If you attempt to redefine a value, the compiler will balk, so that's never going to end up in your code. Now, why is that useful? It means when you're looking at your code, you just don't need to worry about what the value of a variable is at a particular point in your code. It has a value, it's always going to have that value is never going to change. And it makes it much easier when you're reading code to reason about exactly what's going on. Now, having covered those ones off, what's a functional language? So who has heard of functional programming? Okay, so most people have heard of functional programming. Who's actually used who's used functional style programming, let's say? Again, most people. It's actually mainstream in most languages now. Who's used a purely functional language, so one that only does functional? Okay, so just one. Now, when I was putting this talk together, I looked at quite a few people trying to describe what a functional language is. I found no good explanations of it. So, and I'm not guaranteed that I'm going to give you a good explanation here tonight. What I would say is that you know it when you use it. So if you have used a functional programming language for a bit, it will be obvious to you what it is. the best way that I can explain it to you at the moment is really the mindset of a functional language. So when you're coding in a functional language, you're thinking much, much more about the result that you want to get to, not the process by which you reach it. So if you're coding like with a for loop, for example, you worry about the order that things are happening in the for loop. That's not really how you think about functional programming. So the best analogy I could think of was a spreadsheet. So if you can put your accountant hats on for a second. So what we've got in our spreadsheet is we've got some data. So we've got these values here. So these are all numbers, and then these numbers as well. And then here we go. We've got some cells that have formulae in them, which are functions. So these are performing calculations on that data. So here are some simple calculations, calculating the mean of our gamer's score there. And then here's a more complicated function, which is taking these values, it's ordering them, and then it's giving you a rank figure. So that's a function that's going to be doing quite a lot behind the scenes. So why am I showing you a spreadsheet? So I'm showing you a spreadsheet because the complexity in this is built up by feeding functions to functions. So this rank function, this rank column on the end, this is feeding in from the mean hourly score, but this isn't a value, this is a function that's acting on data. So the complexity of the spreadsheet is achieved by building functions on top of other functions. Composing functions would be a good way to put it. And the other thing that I want you to notice is that at no point have I specified to the spreadsheet engine what order I want it to calculate the cells in. Conceptually, it just happens all at the same time, and I don't need to worry about what it's doing. So whereas if you were putting this spreadsheet together as a JavaScript app, you'd need to make sure that you'd calculated the mean score before you attempted to calculate the rank. And in fact, moreover, you'd need to make sure that you'd calculated the mean score of all of the things in your set before you calculated the rank. With here, I don't have to worry about that. And that's very much true of functional programming, and certainly in Elm. You don't think about the process, you think about the result. That may make more sense when you've done some functional programming, and you can come back and tell me whether or not that's true. So, moving on to Elm. Now, Elm has something it calls the Elm architecture, which you might see abbreviated to T if you start reading stuff. That confused me for a bit when I was looking at forums. I was like, why are all these people tea drinkers? And they're not. They're talking about the Elm architecture. So Elm produces HTML for the browser to render. And then something happens. So something happens in the browser, and it sends a message back to the Elm runtime. The Elm runtime then responds to that and generates some more HTML. So that's not very complicated. In code, it breaks down to three parts. So we have the model. So the model is the data representing the state of the application. We have the view. And the view acts on that data to render the page, and indeed acts on only that view to render the page. And then we have an update function, which receives those messages and changes the state of the application. And that's it. Now, if this is sounding spookily familiar, it's because Elm has actually really heavily influenced Redux, if you've used Redux, and Vuex. I certainly used Vuex when I was using Vue. Very, very much about managing state as a single item, and being very controlled about how you change that state or mutate that state is how Vue would term it. So you'll notice I've talked about these three things. I've not talked about objects. Elm doesn't have objects. I've not talked about components. Elm doesn't have components either. So Elm has data, has the state of your application, and it has functions that act on that data, and that is it. Okay, here we go. So let's get into some code. So has anybody used Haskell? 1, 2, okay. So the Elm compiler is actually written in Haskell by Evan Splitsky, and the syntax of Elm is very, very heavily influenced by Haskell. But if you've never seen Haskell, worry not. Haskell is a language I love. It has a brutal learning curve. Elm has a much, much more gentle learning curve. If you want to try functional programming, make Elm your first port of call. So let's jump into what an Elm app looks like. So I don't want to linger too much on this page. I've included it for completeness. So what I've done here is I'm actually showing you the code that is running this, this presentation app. Elm is a modular language. If you're familiar with ES6 modules, very much the same, nothing too surprising there. The line with the colon on it after main, that's a type definition. So you can put type definitions in, and indeed I would generally recommend it. That's probably one where it's less important, but I definitely put them in. But if you don't have to. So Elm will actually infer the types for you. So there are times when it's obvious kind of what the type of something is, it's not worth writing, and that's fine. It reduces the amount of code that's on the page. And here we have some of those functions I was talking about. So the ones that I want to focus on for now are the view and the update functions that you can see being defined as part of the program. But as I say, I'm not going to worry too much about that one. More interesting is our model. So if you remember, our model is the data that represents the state of our application. Now, my presentation application, I've deliberately kept as simple as I can. So in my application, I only have two records. This is a record, so I have a record with fields. 2 bits of data that I'm interested in. So one is the index of the current slide, which is an integer, as you can see. And I've got my array of slides. I've chosen to use an array just because it makes it slightly easier to get it back. Functional programming uses a lot of lists. So generally you see lists. And indeed, you can see in the initialization function, you can see I'm actually taking that from a list of slides, which is a function that I'm not going to show you. That's got all my kind of content in it. What I would want to draw your attention to is the very fact that the initialization function exists, because it has to. Because in Elm, there's no null, there's no undefined, so at all times your variables have got to have a value. So that's why that initialization function's there. Okay, next up, we've got the view. So I told you this took the data, takes our application state and turns that into HTML that's going to be displayed in the browser. And you can see that very clearly in the type definition up there. So that type definition is saying it's taking our model and it's sticking out the exact type that the Elm application needs to put HTML. Don't worry too much about that. And you can see my view function here. So probably the best place to start looking at is from the body. So you declaratively write your page. So if anybody used JSX in React? Lots of nods. Okay, very, very similar. So you're declaratively putting your page together, and then you can use subfunctions. So for example, my current slide is in fact just a function. So that's a function that's going to render my current slide. Now, the bit I'd want to draw your attention to here is in the attributes that are on my main element. I've got on key up, so I'm using the keys to navigate my slides, and then passing what I get back into a function to turn that into a message. More obviously, I've got my on click event, and that is going to move to the next slide. So if I press my mouse, there we go. If I click, it will move on to the next slide. So we talked about updates and Elm sending messages. So this is the message type that I have defined for this application. So the message type includes everything that might change the state of your app. And I have 3 things. This is a custom type. So Elm talks about having a type and then the variant. So I've got a variant of next slide, a variant of previous slide. I also have one which is no operation, mainly because I need to do something when I get a key press that isn't a key press that I'm interested in, and I just send that there. But next, basically, you move to the next slide, you move to the previous slide. That's it. That's all my application can do. That's all it's ever going to do. And if I wanted it to do something else, I'd have to define that here and then change my update function, which is here. So again, you can see from the type definition at the top, the update takes the message. So that's the message it's receiving from the browser or from elsewhere. We'll come to that. It's also taking the current state of my application and it's giving back the new state of the application and something else as well, which I will talk about. But you can see it's giving back another model. And because there's only 3 things that can happen in my application, here they are, and they're all covered off, and indeed they must be covered off. Elm will insist on that. If you miss one, the compiler will balk and tell you to go and deal with it. So I've got my next slide, and that's just doing some fancy adding 1 to my slide index and checking I haven't gone too far. Previous slide, which is taking 1 from my slide index and making sure I haven't gone too far. And this slightly kludgy knob that you don't need to worry about. That, as I say, that's just for keys that I'm not interested in. I send them there, and that does nothing. So how are we for time, James? Let's have a look. Oh, I'm well over. I'm so far over. I'm so sorry. I missed your little wiggle. Okay, right. In that case, I will skip over these things and jump to, they were optional slides anyway, and I will jump to some notable tools, which I'm not going to read out, but when I put this up, you can go and grab those later. Having run over massively, I'm very sorry. Feel free to ask questions. Thank you very much.
Thank you a lot for your talk. I have a couple of questions. Yes. So you said the latest update of the compiler was like in 2019. How you can guarantee that the compiled code will work in in all browsers with all the breaking changes they give or how it's matching the, let's say, new specs that we are getting for ECMAScript and so on?
It's still maintained, Elm. It's definitely not been abandoned. There was a big company, I can't remember which country, there's somewhere in North America, I couldn't say whether it was the US or Canada, called No Red Ink, and they've got a big investment, and they in fact were paying Evan Splitsky for a long time to maintain Elm. It's now in a software foundation, and I don't know, it's still maintained. Browsers, I've certainly not had a problem. You know, it is compiling to ES5, not ES6, but all browsers still support that at the moment. If there was something in particular that you wanted to do, you can, Elm actually does talk to JavaScript. So for example, the big app that I've written, I need to do quite a lot with web audio. Now the web audio API does not lend itself at all well to functional programming. It's not been designed like that. So rather than trying to do something really funny, I basically just handle all of my web audio in raw JavaScript, and then Elm has something called ports where you can basically like push data back and forth. So I think if there were ever to be a feature that you needed, in terms of compatibility, I don't know. I would certainly hope that since he's maintaining it, Evan Splitsky would step up and make a change. But I've not had any compatibility issues. Yeah. Like
for the cases when you're, let's say, when you're gonna use WebAssembly or some like dynamic importing and so on, like all some new APIs, I would say, or even like a big changed behaviors or changed, let's say, for example, the very minor thing, let's say in the keyboard events, the key code's gonna be deprecated, for example. And there are a lot of stuff that's going to be deprecated. How I, as someone who does for production for some corporate, be sure about the like my app will not be down because of the because of Elm is not fresh updated compiler.
As I say, so I said the account guarantee that I'm not, I'm not a contributor. I started working with Elm when 2019 was a lot closer. To a degree, it gives me confidence that it's not been updated because there's been no major issues with it. There are, so on the key up stuff, the key press stuff, that's in the documentation. It certainly talks about like when this changes, we'll add these other functions, but that's not happened. That's not happened yet. Yeah, sorry. You probably need to make your own kind of risk judgment on that one. My feeling would be browsers are, JavaScript has stabilized to a large degree. It's not like it was like 10, 15 years ago. And I would be surprised if browsers don't maintain a high degree of backwards compatibility for a long time.
Because we still get like problems with Safari, which is new Internet Explorer.
Okay.
And just before I pass and a couple things maybe about the asynchronous, how asynchronous is implemented.
Yeah, it's brilliant. You don't need to worry about it. So So Elm would receive asynchronous, so the result of if you make an HTTP request, for example, right? So you don't have to worry about it. So you send it off. So you might have noticed I sneaked past, let's see whether I've got it here. So I sneaked past a definition on the update function. So as well as returning the new state of the application in a model, it also returns this command message. And that's basically your opportunity to tell the Elm runtime to go away and do something and come back when it's done. So so you send off an HTTP request and you tell it what message is going to come back. It's going to kind of be tagged with when it comes back, and it just comes into your application. It hits the update function like any other return value. So there's no kind of async syntax or anything. It's just weaved kind of imperceptibly into the way that Elm handles all of the messages that it receives.
Is there all this rendering happening client side, like in the user's browser? Yes. So like so it is happening client side. Yeah. Okay.
So Elm is entirely client side. There is no. It does use a virtual DOM. Yeah. So in the same way that React would. Elm makes some fairly bold claims about its speed. It claims to be very, very fast. I'm not sure that I would expect somebody who's written a tool to ever put up a graph saying that their tool is rubbish. Yeah. That said, I've been very pleased with the performance that I've seen.
So it's like first paint entirely blank, and then it like loads in afterwards. If you get what I mean. Like, is there some scaffolding that Elm does that?
So you can. That's an interesting one. So you could put some scaffolding in. Yeah. But no, the first paint would be blank, as you say. I mean, I'm aware I don't use it. Is there not some React component that kind of renders a static version so that it doesn't? Server-side rendering. Yeah, it's like the paradigm that, but no, Elm won't do that. And also, is it doing an entire repaint on every? No. So like its subcomponents are, it can like walk the tree, and if a component if function's inputs change, it's only the descendants of that function. Yeah. So you've got the virtual DOM doing a diff. Yeah. The joy of functional programming with functions is that if your arguments haven't changed, what's coming back hasn't changed, and Elm can be smart about that. And so you need to be a little bit smart. So in my where are we? Okay. So in my view function, so this is obviously a very simple view function, but for a more complicated one. I haven't actually even got a function here. So my current slide is actually a function. I mean, everything's a function, but current slide is a function that does some rendering. If that were to take some arguments, now I could pass that the whole model, but that means if the model changes, Elm's going to have to rerun that function. Whereas, let's say that just needed, if I were passing it, I don't know, some string value that was part of my model, I'd just pass it the string value, and then it doesn't need to re-render. And there's also, it's got some other optimizations. If you've got lists, where which would be quite common, right? So you get a list of stuff and you're rendering it. It's got some optimal functions where you can key them. And that way, it doesn't even need to do the diff. It will just look at the key. So if you've got lists that you're adding and taking away from, that's also very, very fast.
Very quick one. How do you style it?
How do you style it? So in my notable tools, there is a top of my list is this tool called Elm Format, and it's basically prettier, but for Elm, and that gives your code a consistent style. So I must admit I don't even worry about formatting as I'm typing. I just kind of save, and it all I've got it wired in to run Elm Format. So I mean you'll find one of the things that people talk about in forums with Elm is that all of your developers end up producing code that looks very similar anyway. The design's kind of obvious when you start doing it. I'm not to say everything's going to be exactly the same, but and I think I don't know if you use a code formatter when you're in whatever languages you're using. I find them a big advantage because you just don't need to think about it anymore. There'll be a few occasions where maybe it doesn't look quite as nice as you might have made it, but on the other hand, you've just saved yourself hours of kind of making sure you've got enough spaces or whatever.
What about CSS styling?
CSS. So, okay, so you've got some options for CSS in Elm. So you can use external style sheets, that's absolutely fine. If you do, you're going to need, actually, do you need? No, ignore that, sorry. So you can use external style sheets. There's also some packages that you can use. So there's one of those that I've listed, which is Elm CSS. So I'm not a big fan. I don't really like CSS, but I've used. Well, you laugh, but let me tell you. So there's so I've used Elm CSS in this app. The advantage of that is it's statically typed, and it actually provides functionality that's very close to Sass. So you can do things like mix-ins and it's more flexible than raw CSS. My favorite is this thing called Elm UI, and that is amazing. It is its own. It's an alternative to CSS, so it's basically like a layer above CSS, and it just makes more sense. So, like if you want to center an image vertically and horizontally, every time I want to do that in CSS, I've always got to look it up. I don't do it often enough. I'm like, maybe I'll be using Bootstrap or something, that's fine. But if I'm doing it in raw CSS, I'll have to look it up. And Elm UI just kind of really takes that pain away. Like if you want to build a design toolkit. Anyway, Elm UI would be a whole talk on its own, and then some, and I would run over on that one as well. So that's enough about
that. Is there a kind of app for which Elm is very good, or any of which it's not so good for?
Pain points. So I would say that Elm is very, very good for most web apps that you would want to write. And when I say most web apps, like the kind of web apps that you would interact with like most days in your kind of daily life. So that kind of click here, enter some text, submit it to the server. That type of app it's excellent at. I'd say when you start to push at the edges, some of the things it just doesn't quite do natively. And so for me, that's been where my pain points are. So interacting with things like video, for example. So my app uses video. It renders multiple videos on a page, and it's fine. But I've had to dive into the JavaScript world to make that happen. And I think I mentioned with web audio earlier as well. And because my app records from the microphone using like the media context and stuff, all of that stuff is not supported natively by Elm. And as a result, I've had to go via ports and write in JavaScript to make that a reality. And that's fine, and Elm is very happy to let you do that. But obviously when you do that, you then lose all of the guarantees that Elm gives you about amazing reliability, no runtime errors, and potentially type safety as well, depending on what you're using when you pop out the other side.
Like Elm doesn't have components.
Components, no.
Okay, so how do you?
I mean, you could try to stuff them in there. And there are times when it might make sense, but no, it doesn't have components. So there's no local state, there's only a central state.
Go then about reusability. Like, for example, if I want to build back React application, I want to have like component for a button that I will reuse, and I will change the styling and everything and data to reflect what I wanted to expect it. With the code, which you give examples to, it kind of looks like you target specific HTML tags. So does that mean that you will need to have lots of Elm files which would target specific thing in specific order, or how do you go about that?
Okay, so one of the recommendations that Evan Splitsky makes is to have really long files, like way longer than you would ever be comfortable with in the JavaScript world. I don't know that I totally agree with him, but it does make sense. It's about, so with functional programming, it's about the data and functions that act on that data. So when you're arranging your code into modules, you basically want a data type and all of the functions that might act on it. And if you've got interrelated data types, then they might need to sit together, or at least kind of very closely. So although I said there's no components, remember everything's a function. So in a view function, I'm anxious of time. I don't want to, I could fire up a more complicated one for you to see. But what I'd do here is, so let's say I had a sidebar, right? So what I'd probably do is, I mean, you can stick everything in one function if you wanted, but that's going to be horrible, and you're not going to like survive that very long. So what I'd do is I'd create a sidebar function that returned, the HTML to build my sidebar, and maybe my sidebar needs some of my data. Probably doesn't need all of my data. It might need no data. It might just be a static list. It might need a selection or something, right? So you have your sidebar function, and then you pass it model.selection. And then so although it's not a component, because it doesn't have local state, you still manage to to modularize your code in a way that's going to make it manageable. And I do the same then for like the main area, or if I were, let's say I was building like an online shop or something, and I had lots of different products. So I'd probably make so I'd have a product function that took some parameter of like product ID and then went and got the right image and pricing and whatever. Does that make sense?
I kind of thought that it would be very long file each time. So that's a confirmation. Thank you.
Yeah, I mean it could be a long file, but it doesn't. When you're working in Elm, it doesn't feel long because the code's very readable. You don't kind of get lost in it. I mean. So a big application that I've built is a virtual desktop. So I've got the desktop, and then I've got kind of apps running within it, and they don't really need to talk to each other. And I just said that was a bit of a pain point for me when I scaled, because I had separate apps and I merged them into one. That was a bit of a pain point for me because each of these apps was really very complicated in and of itself. And putting them all just into like one big thing would have been awful. So that I have separated off, so the design pattern for that is that you use the kind of Elm architecture, the update view model, but you use that for each bit, so for each component. So that is the closest I'd say that you would come to components.
Is that like a public repository that people can check out?
I'm afraid not. No, that's proprietary. That one. Sorry. But I'd be happy to show you. I mean, I've got the code here.
You can answer this in a word. And before I ask this, I don't know if you noticed a giant duck behind you. It's been giving you some serious side eye.
Oh my word!
You've been talking about static typing. This is a massive question, but just out of curiosity, do you think it's a mistake that we built most of the web in dynamically typed languages?
That is a big question.
You can answer in one word.
Yes. Yes, I know this is an odd thing to say. It's a JavaScript meetup. I don't like JavaScript. Right? You've got so think back. So Elm was written in 2012. All these frameworks were springing up. Why were they springing up? JavaScript was unwieldy. So I didn't mention it. So you must have seen the images online. So you've got like O'Reilly JavaScript, like the complete guide, which is like, I think the version from back then ran to over 1,000 pages. And then you've got also published by O'Reilly JavaScript, the good parts, which runs to 170 pages. And I mean, a lot of that's about JavaScript and the way it's evolved rather than dynamic typing. But no, I love strong typing. Horses for courses. I'm very happy to use Python for quick and dirty, shell scripting. It's fast and you can get stuff done. But for me, if I want stability, strong typing is always the way I'll go. And certainly from a security perspective.
Yeah, I've just been interested in seeing companies like Stripe build static typing on top of Ruby, and that seems to be the direction that a lot of people are going now.
I think personally, I'd go for a language that had static typing built in. I mean, again, for me, that would be one of the reasons that I choose Elm. So if anybody was here for last month's talks, there was Tom Bedard standing at the front. He was talking about their stack. So he was talking about, so they're using JavaScript, but they're not, because they're using TypeScript. And then they're using JS for immutability. And so you've got JavaScript, but then you've slapped kind of static typing on top of it, and you've slapped immutability on the top of it. So why not use a language that's got those kind of designed in from the start? Because then they're designed in, and you don't have, you don't have some of the kind of strange syntax that comes with it. I mean, again, for me in JavaScript, closures, they always feel really untidy when I see them. I mean, it's not that they don't have their uses, but they just look really untidy. Whereas in this, everything's a function. So it's just, it's just written as a function.
Please join me in thanking Ross for an amazing talk. We have the room here for 20 more minutes for networking purposes, and then everyone is invited to the Sky Bar at the Hilton over the road to continue the revelry. A couple of thank yous. Thank you to our two speakers, Ross McKelvey and Rory Malcolm. Thank you to Alan for organising the live stream, and thank you to everyone that watched the event at home. Thank you to KPV for sponsoring the pizzas. And thank you to CoClan for providing this beautiful venue, and in particular to Nicole for being here and looking after us tonight. Let the networking commence. Thank you to you.